So hello guys, welcome to our next video on the playlist Google Earth Engine for the water resource management. So in today's video, we are going to explore the datasets regarding the precipitation or the rainfall. So we have one of the very useful product which is called as the CHIRPS dataset. So it stands for the Climate Hazard Infrared Precipitation with Station. So it's an satellite image dataset which has been uh, gridded with the ground stations also. So it's a very accurate dataset, and we will explore how the dataset is and what is the available dates. So there are daily available data for the precipitation, and also there is a pentad data. So the pentad stands for its data aggregated over 5 days. So let's explore both the datasets in today's video. So let us start by creating any region of interest in our uh, map section. So you can add a point, and let's call it as region of interest. Okay, I'm choosing a point in Karnataka of India. So let's search our dataset as CHIRPS. So here you can see the two datasets are available, the CHIPS daily and the CHIPS pentad. The climate hazard center for the infrared precipitation with the station data, and it is precipitation with the station data for the pentad cycle. So let's explore the dataset for the daily basis. So here you can see the dataset is available from 1981 till present, and it has a single band called as a precipitation. Its minimum value is 0, and maximum value starting from its maximum value is 1444 uh, per day. So units are in Since we are exploring the daily dataset, the units are in per day. So let's import this. Remember, it's an image collection, it's not a feature collection. So let's rename it as uh, daily. You can rename anyways as your convenience. So let's create a variable, say variable rainfall. Okay, select our dataset and filter it to bounds. It should be daily, and filter it to our bounds ROI, and you can also filter it to date. So let's say I need a data set for this year precipitation in the month of June to 2024 till the end of June. Okay, so let's just see how much images are available. So there should be 30 images, because since it's a daily data. So let's print our variable rainfall in order to know how many images are available. So click on the run. Our image collection is loading. We have 29 elements, so it has excluded it. So let's add 7 1. Yeah, now we have 30 elements starting from 1st June to 31st of June. So here you can see the features and the dataset availability. 1st June 2024, 2nd June 2024, 3rd June 2024, like that we have till 30th June 2024. So you can select any of the single image in order to know the rainfall of any particular area. And one more important information I forgot to tell is that this band is of 5000 resolution, 5566 meters of resolution. So through this way you can have the daily precipitation data set. So let's add this to our so we can add a monthly rainfall by having sum of all this. So you should use the reduce function, and ee dot reducer dot sum in order to have the addition of all these precipitation which have occurred daily over a month. And you can click to our region of interest, and we'll add it down to the layer. So it's a June 2024 rainfall. So before clicking on the run, let's define our region of interest instead of pointer. Let's select the entire district or the entire Karnataka. So let's search for our FAO dataset which has the first administrative level division. So let's import it and let it be a table. You can say it as a point, and let's define our region of interest to Karnataka state. So variable ROI is equal to, so our table which consists of the state shapefile of the entire country, and filter it to bounce to the point. So let's click on the run now, it should work. Our image is loading. uh, it has changed automatically, so it should be ROI. Let's give a run again and check our geometry. So yeah, you can explore the layers panel. Precipitation sum is there, extend to 100%. So you can see the range is from 6 to 1172 per day. So you can give the different palette colors. So let's say we have a pale blue for the low rainfall, and a little bit a darker color for the medium rainfall, and very high rainfall regions we have the more darker blue color. So let's apply it. Yeah, so clearly guys, you can see in the western Ghats region of the Karnataka, the precipitation is more, which are near to the coast as well as which are on the high hilly zones area. And as you move away from the western Ghat region, the rainfall is less, which is a rain shadow area. It's all a drier region. So uh, like this, you can explore for a single month, or you can also explore for an yearly data. So I am using here a daily data set. You can also use a penta data set. So instead of using 5 days data, it is better to take the average of daily data, which will be more accurate in uh, collections. So you can also plot a chart of this, showing how much rainfall has occurred in each day of a month. So you can use ui.chart.image.series function in order to show the chart. So let's try that also. So in order to plot a chart, we should have an image collection. So let's remove these two. We are not keeping to our region of interest, and we should not have any sum. And let's remove this also, or else we can create a separate variable. So just paste it down, and you can say it's a June month variable data set, and it should be an image collection. So we removing the reduce function and clip function, and we are ending our variable June here. So let's create one more variable called chart. So variable chart is equal to, so we are using the function ui dot chart dot image dot series, because we are having a series of image, a collection of image. and you can just click on the control press space button in order to get the arguments and the requirements of this particular function. So the image collection is June, and our region is ROI, and our reducer we are using is which is the reducer we should use. Since we are having the daily plot of data, the data is already available in a daily databases, so there is no need for to use any kind of reducer, or else you can use no let's have it that way, and if any error occurs we'll see later. And the scale is 5566 meter, which we have already seen, and the x property, y property and all not required. So just close the brackets, and we should print the chart now. You could be able to see generating graph in the console. So just make it a broader connection. So here you can see this is the rainfall, which is in the y-axis, and in the x-axis we have the dates. So the interval is between 2 days up to June 30. So from here you can also download a CSV file, a SVG file, or the PNG in terms of image. If you can download to CSV, you can have a further analysis in your Excel sheet, and simply you can download the PNG in order to paste it in any of your documents. So clearly the June 5, I think so, clearly June 5 to 6 is exposing the highest amount of rainfall, 34 mm per day in the Karnataka region on an average. So guys, I think you have understood how to calculate or estimate the rainfall in any region across the globe. So again, this data set is available globally, uh, and you can have it for any region in the world. So once again, if you have any kind of queries or doubts, you can always post in the comment section, and feel free to ask anything. So thank you guys, thank you for watching, stay tuned for the next video.